Question number 8, what do these symbols stand for? Well, AQ, that stands for aqueous. An example of aqueous would be something that is in a solution or dissolved in water. For example, aqueous salt would be salt water, or aqueous sugar would be sugar water. Vinegar would be another example of an aqueous solution because when you buy vinegar, it's not just pure vinegar, it's vinegar in water. G stands for gas, things like carbon dioxide or oxygen or nitrogen. S would be solid. Any metal on the periodic table is going to be solid, except for mercury. And then L is liquid. Best example of a liquid is water. Number 9, which atoms are always diatomic when alone? There are 7 of them. If you can just remember Hoffenberkel, hydrogen, oxygen, fluorine, iodine, nitrogen, bromine, and chlorine. All of these will be diatomic, which means that when they are elements, they will be in pairs. I like to think of those Hostess cupcakes that comes in packs of 2. Number 10, how are solids represented when they are alone? If you have, for example, iron metal, it's just this. So it's no diatomic, no charge. It's just the elements symbol. And then, of course, you could put a symbol of S behind it to show solid. Number 11, your lab team decides it needs to produce iron metal. They know that in doing so, sodium oxide will also form. This is acceptable, so they decide to take sodium metal and combine it with iron 3 oxide. What is the word equation for this reaction? Well, word equation is using the chemicals and just their full names. The tricky part of number 11 is its reverse. They decide to take sodium metal. So this is what they're starting with. I'm going to put a circle around the reactants here. And this is a half circle like so. And then a square around the products. See the produce here? That's a good sign that this is a product. So they produce iron and sodium oxide. Okay. So the word reaction is going to be sodium plus iron 3 oxide produces or makes iron plus sodium oxide. So then the chemical equation, sodium is, as we can see here, a metal, and it's just an element, symbol Na. It is not diatomic, so we can just write it as Na. Iron 3 oxide, this means iron has a +3 charge, so I'm going to do some scratch work up here. Iron with a +3, oxygen with a -2. So I need another oxygen, so I need another oxygen, and one more iron. Now I'm at, +6 and -6. So I have 2 irons, Fe2, and 3 oxygens. And this is going to be an aqueous. It's in a solution. Next is iron. It produces iron metal. The symbol for iron is Fe. It's a solid. And sodium oxide. So sodium is Na, oxygen is O. Let's polish it now by looking at the charges. Scratch work over here. Sodium's a +1, oxygen's a -2. So we need another sodium, and so it's Na2O. This will also be aqueous. Okay, so that is our chemical equation. Tricky part of this one is that the products were written first and the reactants were written second. So you have to read and see that, oh, produce, that means this is the products. Number 12, you will win 5 cookies, yes, if you can make iron 3 phosphates. The easiest way you decide to do this is to use iron 3 chloride and ammonium phosphate from the shelf. A byproduct of the reaction is ammonium chloride. Let's circle the reactants here. You decide to use iron 3 chloride and ammonium phosphate. Okay. A byproduct is ammonium chloride. And then remember, the whole point of this reaction is to make iron 3 phosphate, so this is the other product. So we need to write the word reaction. So iron 3 chloride, that's reactant number 1, plus ammonium phosphate is going to make these two. Iron 3 phosphate, that's the whole goal of this one, plus ammonium chloride. Okay, time to write the chemical equation now. Iron 3 chloride, iron is Fe, chlorine is Cl. Let's polish it now. The charge of iron is +3, and the charge of chlorine is -1. So we're going to need 3 of these chlorines to have an overall 0 charge, so it's FeCl3. Plus ammonium phosphate. Ammonium is a polyatomic ion, it's NH4, it's a +1. Phosphate is PO4, it's a -3. So we're going to need 2 more of these ammoniums. And so now we have 3 of these ammoniums and a phosphate. And that's going to make iron 3 phosphate. Iron is Fe, phosphate is PO4. Check the charges. Iron's a +3, phosphate's a -3, so that's good. Polished. And ammonium chloride, ammonium is NH4, chloride is Cl. Check the charges. Ammonium's a +1 and chlorine's a -1, so this is good to go. Number 13, label the coefficient and subscript. Coefficient is the big number in front that tells the number of molecules. Subscript tells the number of atoms. So this is the coefficient is the first one. Let's just probably going to save some ink here. And subscript is this one. Cool. Number 14, consider this barium phosphate. How many barium atoms does this compound have? All right. Well, there are 3 barium atoms here. But this whole molecule's, there are 3 of those, so there's a total of 9 barium atoms. How many phosphates? Well, this is phosphate, and there are 2 of them, but then in each molecule. But then there are 3 total molecules, so that comes to a total of 6. How many phosphorus atoms? There is 1 phosphorus atom here, but then this is multiplied by 2 because of the 2 here, so now there's 2. Times 3 is 6 phosphorus atoms. And how many oxygens? There are 4 oxygens inside the parentheses. Times 2 is 8. Times 3 is 24 oxygen atoms. Number 15, balance this equation. Okay, step 1, dotted line down. Step 2, coefficient lines. Step 3, atom key. We've got tin, sulfur, and oxygen. Step 4, atom tally. Tin, there's 1, 2 sulfurs. Notice I'm being very careful to line up here. 1 tin, 2 oxygens, 1 sulfur, oh, and 2 more oxygens. So I have oxygens in 2 places here, so the total here is 4 oxygens. All right, our tin is balanced, so we go to our sulfur. There's only 1 sulfur over here, so I'm going to put a coefficient of 2. That changes this to 2, and it changes my oxygen to 4, which changes the total oxygen to 6. Now my tins are balanced, my sulfurs are balanced, my oxygens, I have 6 in the products and 2 in the reactants. So I put a 3 here, that changes this to a 6, and now we're balanced. 1 tin on each side, 2 sulfurs, and 6 oxygens.